about the dream that turned into a nightmare and how we wake up. And I'm the thing that stands between you and your lunch. So I'm trying to be fast enough. So yeah, my name is Radoslav Stankov. I write a newsletter called Tips Stankov. I am the CTO and a co-founder of a startup called Angry Building. And because my slides are going to have a lot of code, they're going to have a lot of samples, and because I'm also hungry as you are, I'm going to do a lot of fast talking. So all the slides are already uploaded, so you don't need to just make some photos here and just be like that. So today I'm going to tell you a story, like once upon a time, like all great stories start in a startup far, far away in the Silicon Valley. And you can imagine the soundtrack of HBO Silicon Valley. So this story happened at the company I was the CTO before, my current one. And I'm not CTO anymore there, not because of this project, but this is a story about when I was working at Product Hunt and we were making a project. So we decided to make this project, and this project started in 2021. And if you noticed, again, there is, oops, where is my cursor? Okay, so yeah, you notice this is the date, 28th of April. And this was the Dream architectural choices. And this project was named Dream. And the idea of the project was, and this is directly copied from the doc, the Dream is short for the dream not writing CSS by hand anymore. This was our dream. And I added this joke there, and this joke here, let's hope V2 is not named Nightmare. You know, there will be a lot of puns about that. So this was kind of our goal of this project. The goal was, okay, we have these new teammates, we were growing the company, we started having like a new redesign, and this was like a good opportunity to build our design system, design components, and things like that. So the goal we had for this project was have a consistent UI across the system. Make it easier for developers to build new pages, like we don't need to wait for design, we can just prototype very fast. We needed to implement the Product Hunt V6, this was the project of the design names. Honestly, designers named the version V6. It's very like, again, I'm better with names, I named the project Dream. And the other goal of the project, we wanted to finally be fully type-safe. We wanted everything to be TypeScript up to bottom, no any's anywhere, to be very safe. And the goal of the project, this was the goals. And what we wanted to build was some foundational utilities for us to be able to use in this project. And to have on top of those utilities some core UI components. And we started very simple. The designers give us, okay, we're going to use the 4-pixel grid, we're going to have the font sizes, the font weights, the color tokens, the layouts, and again, on the design principle docs, this was like the layout, this is how everything going to work. And again, we are just trying to start building this, and we started working on this project. We started building stuff by stuff. And this is Product Hunt V6. This is how the final version, it looks nice, even to this day. And again, this was the motto of the team, move fast and have breakfast. And we basically started building the design system. And again, a design system have those elements. So you start with the system, it has design language, it has design kit, it has component library, developer sandbox, and documentation. Like, this is the things that you need for a design system. And our design system, I think it was decent, and nothing groundbreaking, but decent. So my talk today is going to focus on our component library, the core components part. Like, the idea there is I'm going to walk you through what were the things we succeeded, why it turned into a nightmare, how we get out of it. So yeah, so here is the documentation part. This is what we had internally. If you visit like one of the internal developer tools, this is, you see all the spacings. Here you see our flex component that allows us to build flex. So flex component, for example, what you can do is you get the dream component flex and you can say it's gap. And you don't need to write CSS, you just write flex gap. Very simple, very nice. We had more advanced components, like we wanted to unify the whole layout system of the website because there is a lot of details between the different screen sizes. Like on mobile, you want one thing on certain sizes. So we had this layout component, which was also part of Dream, which honestly worked very well as well. It was like you just import this layout component. It can have a header, it can have a main site, it can have a site. And a developer, imagine again, you need to build a page. You don't need to worry about those things. And we also integrated this with Figma components, and our designers also follow that, which is not a given. Another component which we have, and every system has, is the button, and this is all the buttons in the system we had. And again, the way we design those button components is we have the button component here, and we used this package name style of components where you have this core button and then you have packages here of its types, like you have the solid, the outline, the text, the icon, the different types of buttons, and you accept them. The buttons didn't intentionally, none of the buttons accepted children, everything was very type safe. And again, this was all the different buttons we have. And another cool thing we did was our buttons were actually very smart. So for example, a button can be a link when you just give it a path. You have on-click handler. And if the on-click handler returns a promise, if it's a wait function, then the button cannot be clicked again. Like this was already built into the button itself, so the developer doesn't have to remember that. Our whole system was built on top of GraphQL. So it was very natural for us just to say, okay, when you click this button, execute this GraphQL mutation. And every button knew that. So the developer doesn't have to think about the loading state, the management, none of that. We had some other cool things. We had like a confirm. So for example, if you click the button, we can ask you, are you sure to do something? We had by default confirm true. If it's true, always are you sure? We can add a custom text. We had this require login, which if it's marked on a button, if you click the button tells you, oh, you're not logged in, show your model and do yada, yada, yada complex stuff. And this actually was very useful. Like if you need to build stuff, think about how much code you don't need to write. And the core of this function, to be honest, because we needed over time those things to be added to things different than buttons, we just used the simple implementation. It was very simple. We just had this on click, and we had this complex hook. And when I say complex hook, it was very complex. It's you just open it and it's very expanded. So this was the button. Another component which I really liked is the forms. Like we as developers, however nice lives we have, sometimes we have to deal with forms. And we have those form components with all their styles, and we had this very nice API for forms, like here, for example, tightly integrated with GraphQL. So for example, you just pass the GraphQL mutation, and after the mutation is done, what will happen? And the system automatically knows if the GraphQL mutation returns an error, it knows how to highlight things, it knows all the different things it needs to do. So you as a developer, you just arrange it. So yeah, everything was very great. When we started using the system, it felt like that. Basically, all the developers felt like this on the whole situation. Like we were like raising the flag, everything is great, we are going to the Olympics. And then we moved to another component. Let's go, like we need to show text. Like, I mean, we have to show text. How else the LLMs would be trained on our content. So this is how we show the text. And we have this text component, which is a text component. You give it an as property to say what the tag is. And we have the different packages here, which is like title, subtitle, bold. And this is the way the text component works. You have the text here, then you have the font size. You can pass the font size. Then you have this padding. So for example, you have those packages of utilities we had for spacings. So a lot of all the core components of Dream, and we also have utilities to make our custom components that can accept spacing properties like P, 1, 2, 3, 4. And because we start with mobile, we need to have different versions. Those P's can accept an object, and we can say the padding for this component on mobile is 1. On our grid, this will be 4 pixels, 8 pixels, and 9 pixels, yada, 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 yada. But you can accept this. Also, the same thing can work on the front end. And it's nice. Like, again, the front end is nice. The whole front end is amazing. In the back end, the implementation looks a bit different. It's a bit more scary, a little bit more hairy. Like this one is the implementation of the text component, and it's short. Actually, it fills on a slide, but there is this Dream CSS classes thing which accepts the whole bags of properties of the component, and then it builds and builds and builds a lot of things. So there is a problem with this function. Like every core component of Dream was going to this one big hairy function. And everything was going there. Every object, everything was generating there. So you as a developer, you're fast. You built a lot of things. Things work. But at some point, we started feeling like maybe we started on the wrong end. How do we get out from this situation without getting... That's not blood, by the way, that's paint. But that's how it felt. So let's see what were the problems of the Dream architectures when we started looking at and started using it across the whole system. So the first problem is all possible class names that we generated for Dream has to be always in our main bundle because we generate them with code, with part object, with part props. We cannot use something like lazy CSS or per CSS or something like that that cleans them up. So let's do some mathematics. I know we are developers and we don't like math, but this is some numbers. If we say you have the gap property for a flex component, you have 14 sizes. We'll have 5 variants. By 5 variants, I mean mobile, desktop, widescreen, smart screen, default. 46. That's not that bad. Let's add the margin. The margin has actually 7 properties of margin. Margin top, margin bottom, margin X, Y, blah, blah, blah. You have the colors. We had around 2,000 classes, and it's like, those are small classes, fluffy, nice classes that slowly choke your performance really bad. They really hurt you. Like, it was a lot. And we actually had even more because a lot of developers on our team were having, it was very easy to add, for example, a new color. Like the designers, designers, they like colors. I don't know why they like colors so much. I know just 3 colors and I'm happy with them. The designer's 120. But the moment when the designer adds 1 color, the developer adds the color in the config file, then we generate 300 classes for all the variants of this color. Okay, if this color is a text color, background color, noise color, yada, 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 yada. So this was problem 1. Okay, that's livable. Let's see problem 2. So everything in our system was in layers. Layer 1, layer 2, layer 3, 5, 6, 7. And everything goes to these Dream CSS functions. So this Dream CSS function always accepts a JavaScript object, iterates through it, does a lot of expensive things, it has a lot of internal logic, and every time you render a div on a page, it had to go to this one function. This one function. So this one function, so this page, very simple page, took more than 2,000 iterations from this function. And this function is not only, it's working on an expensive garbage collectible items, like it generated objects and it generated a lot of things that needed to be garbage collected. So think about it, like a lot of people would say, yeah, this function, you don't need to micro-optimize, but if something is being called more than 2,000 times on each render, that's not once and it's done. It's like on each render, the way React works. And you started to be why I'm not so happy anymore. I am a bit shocked here when you started notice that. Another thing which kind of become like a problem stemming from the other two was we were having a lot of utilities and it was very easy to add a lot of the props. Like, for example, every component we had those 30 props for spacing. It needed also to have properties for different components. And you know the text component has this S property, but what if you want to have a link? It should accept a link. And all that stuff become very complicated. So yeah, the code started looking a lot like that. From the nice car, it moved into like this thing. And again, this component, again, it looks very small, it's very, very nice, but it has a lot of external complexity. Like, for example, this thing, iText property styles. Like, this is all the styles a text component can have, and it's like 40 properties. And a lot of developers are like, oh, I want to do something custom. I would just copy this, use it there. And at some point, you move to this screen of death, and it starts appearing in places you don't imagine. And this was, again, the situation where my team were up to. Like, we were kind of, again, stuck in that situation. We were, oh my God, what should we do now? And it was like kind of obvious. So we said, okay, we need to fix the situation. Like, there is a lot of problems here. And the problems shouldn't, how do we solve that? Like, I mean, things work, they're not like falling apart, but that's a big problem sometimes. Like, if you have a project and the things are kind of not working, but it's not like a burning issue. It's like dead by 1,000 bunnies kind of situation. It's a very hard thing to have the will and the power to kind of say, oh yeah, we need to do something more complex. We needed to wake up. So we started a project, and again, I'm very good with puns. So I named the project Wake Up. The project to remove Dream was named Wake Up. And somebody wanted to say, this is the project, it will be Wake Up, it will be very silent. In my head, it was more like this. That's how it felt for the project to handle this situation. And when you have to deal with projects which are like this, and it's very important for you not to just start doing stuff. You have to start thinking a bit, because again, being in this situation often gets you there, and everybody says, oh, you just start over. We were just going to write everything. We're going to build a whole new thing. And it's like, yeah, but if you think about it, our system actually had the good, the bad, and the ugly parts. It had very things that are actually good from what we had, and there is a lot of bad things, and definitely there is an ugliness to the whole thing. So let's not just rush it, start from scratch, believe that we are a lot better than we were a year ago, 2 years ago. Let's just actually see what was actually wrong with the whole situation. Because again, the whole system worked. Like, this is the good stuff, is developers were actually being able to ship stuff very, very fast. The problem is, because they were building the stuff very fast, nobody actually took time to think about the performance, the whole issue. The biggest problem here was the performance. So the good part, the use on click, actually the button component was very awesome, because you don't need to worry about, oh, the asynchronous stuff, oh, how do we do network calls, how do we do validation, what if the mutation fails? On click was great. The other thing, which was amazingly good, was the form components. Actually, developers liked making forms. It was like no biggie for them. So the form components was something that's very good in the system. So it was really nice. Also, a lot of the core APIs were very consistent. Like, we actually had some good naming schemes and all that works. And again, the key for the business, and again, here the situation is, think about all the business value is developers were able to ship stuff really fast. So if you go to the management, which in that case was me, and somebody says we need to rewrite this because it's ugly, I would say, yeah, but show me the metrics, give me the data. All our developers are actually shipping stuff very fast. And I was like, yeah, but that's what's the bad stuff. And the key bad stuff is performance. And why do we care about performance? Why does performance matter? And everybody thinks, again, we are developers, we are like, oh, we should be very fast, everything should be performant, but why does it matter? For us, number one reason why performance mattered, surprisingly, was Google. Most of our, Google was a very big traffic acquisition source for us. And Google, for the last 5-6 years, actually measures the site performance, and it measures how fast is a website. And if your site is very slow, they don't rank as well. So performance is a very essential thing for Google, one of our big traffic acquisition costs. We actually had a project maybe like 5 years ago, 6 years ago, where we wanted to increase our SEO optimization game. We wanted to be very big SEO optimizations. And the biggest 2 wins we did, and this actually made our site rank in the top everywhere. We do 2 things. First was we introduced something called badges, where our customers can embed a simple link with a button, plain HTML link and an image with SVG on their websites, which increased the number of upcoming links to us, which was a product feature. The second one, surprisingly, was increasing performance. Just a developer going to all our most Google important pages and sweating out the performance was very important. So performance is very important for Google. Another thing we have also noticed is that if stuff is sluggish, people close the tabs. People want to open stuff and it needs to be fast. And people kind of feel a lot of that. Also, one thing is that, again, people have, not everybody has the 5Gs. And internet downloading speed is a thing. If your CSS has not been loaded, your stuff doesn't look as it should. So this was really bad. Like the big key thing was the problem here is our performance. The second problem was those spacing props that I mentioned, that the text component can accept margin padding, top left, right, X, Y, blah, 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 and a lot of other components can accept this, was actually making developers to do a lot of like weird hacks in order to align elements because it was very easy. Also, the core components, we started noticing this pattern where, yeah, we are building stuff very fast, but if something is not in the core components, actually the time to build it increases a lot. Like if something needs to be a bit custom and our system doesn't support it, it actually triples the time that it usually takes. It makes it a lot slower. So in certain places, yeah, we are fast on the default case, but often if you look at the interesting projects, the one that kind of pushes the boundaries is very complex. Another thing is our components accepted a lot of properties. If your components accept a lot of properties, that by convention means you actually have a lot of variants that you need to test and make sure your core components work. So if a developer wants to make these core components better, we were breaking a lot of things UI-wise, just changing some stuff. And that's the big problem. Like a lot of people say, oh, it's really bad if you destroy some functionality. But the thing about it is for functionality, for business logic, I have tests. I don't have tests that the 2 elements don't overlap with each other on the surf and looks ugly. There is nothing right now, hopefully AI with vision would tell us, oh, this looks ugly, as a AI suite. But that's the thing. We were breaking some things very silently without knowing. And it was mostly when we click around and somebody looks, why? This button looks so weird on this page. And it was like, oh, we added this new property which conflicts with this 5.6. Another thing is, one of the goals of Dream was not writing any CSS, and we noticed that we still did a lot of CSS for things like borders and shadows. And those were very inconsistent across our whole system because we didn't have a utility where to put the borders and the shadows. And some of my developers actually suggested, oh, let's add a border and a shadow property. And I'm like, shut up. You're making it worse. And also, like, we noticed another interesting thing also related to performance. The two biggest offenders in our system, the ones that were the biggest problem, was this flex component and this text component, because there were always something needed for them, because everything is flex, everything is text. And those two components, a lot of times developers, instead of thinking, oh, how can I just build this with 3 HTML elements? Let's do 5 flex components. It turns out, if you do stuff very fast, you don't think about the consequences. Don't think about the performance. Like, everything is slow. You don't notice that you actually do stuff with like 5 diffs when you can just use a single diff. And this, again, compounds. Often compounds, especially we have in the database world, there is this problem called n+1. When you have a page, which, for example, selects a list of comments, and then for each comment, it makes another query to fetch the outer of the comment. That's called n+1 problem, which means every comment you have makes an extra database query. And this is a performance problem because locally, you most probably are very fast. The database is very close. And how does this relate to HTML when I'm telling you this? Let me think about, oh yeah, I remember why. The reason is the same thing happens with HTML. Imagine you have a component that represents a comment, and you have a list of comments. I have 100 comments. Every extra diff, every extra piece of code that needs to be executed per comment is multiplied by the number of comments, and you don't control for that. So we noticed a lot of that. So that was a lot of the bad stuff, the ugly stuff. So the ugly stuff. The first thing was we had this nasty as property. So I can imagine how many of you have ever created a property name component as or something like that, where you have a React component and you need to change the tag that's the core component to, like, from div to span, for example, or pass another React component there. And what happens if you pass another React component? How do you actually orchestrate all of that? Where does this go? Especially problems with links and other things like that. So as was creating, it was powerful, but it was making a lot of inconsistencies. Also, again, the flex component wasn't flexible enough, again, pun intended. Flex component, because we wanted to basically represent the whole CSS there, wasn't flexible. The text component was very complex. Also, the designers felt very constrained, which was a feature, not a bug initially, but at some point I started to notice this pattern where, again, we know designers, we work with them, maybe some of them are among us and hiding right now, and I like you guys or girls, but sometimes we know the designers always want to deviate from the core system. So making it hard to deviate from the core system is a feature, not a bug, of design systems. However, there is a very thin border between a constraint for good and constraint that actually stops us from thinking about building new features. And I have noticed that a lot of the push initially was for things that were actually, okay, that's actually a good idea, and this is really constraining us. Also, another problem with Dream we have was it was desktop first. Like the way we built most of the traffic was actually mobile, but most of the developers develop on desktops. Nobody was actually coding on their iPhone, and nobody uses Android anyways. So every design, the way Dream was architected was we specified the desktop version first, and everything goes downwards. And this creates a lot of edge cases and a lot of problems on mobile. So mobile was always an afterthought. And again, if we zoom back, think about it, a lot of the core issues of this thing was coming from this single one function, Dream CSS classes. Because everything comes here, a lot of those things, good, bad, and ugly. So what we did here was, okay, this was the report we did. This was basically spending all that feedback, checking all of that, and seeing, okay, what should we do? So after some discussions, one thing we decided to is replace Dream CSS with Tailwind CSS. The idea there was we actually really liked the utility classes. Dream basically had the utility classes. So we decided, okay, well, let's switch to Tailwind. It's industry standard. It has this awesome feature where it goes to the whole system, and if there is a class that's not used, it's being able to remove it. Again, Tailwind has a lot of issues. So I actually wrote a really nice post about tips how to use Tailwind and what are my strategies. So yeah, wink, wink, advertisement here time. So, okay. We have the thing. So now it's time for battle strategy. Now we need to figure out, okay, how can you actually get from here to there? Because again, we can be very nice. A manager can tell you, oh man, we should do this, do it. But we should have a strategy and we should have a battle plan. And we had one. So the plan was in 5 steps. So we thought a lot about those steps. By we, I mean me, because I was the one who needed to do that at the moment. So let's see the battle plan. So, first step. Dream actually used utility classes, and they were surprisingly close to the Tailwind classes, even us without using Tailwind. So we first needed to unify the class names that were generated from Dream to Tailwind. We needed to have one-by-one mapping. So when we remove everything else on the subject, that can work. Then there was an intermediate step where the Dream CSS classes function is replaced by a function, so a function that's called TW from Tailwind. So the Dream CSS classes accepts an object, and the TW should accept a string and do, and I'll show you this later, type safety checks in this string that includes all the proper class names for this class. Then the step 3 is remove the biggest offenders of Dream, flex and text, because after the whole research, it turns out the biggest issue were flex and text. And 4th step is again, the step 3 also included inlining all those spacing properties across the system. Like this is basically the step 3 was inlining everything. Like you use this component, now you just use diff plus classes. Step 4, switch to Tailwind. Step 5, the simple one, just replace TW helper with this ESLint plugin, and you just pass string all around. So performance-wise, what we were going to do is we're going to remove all those Dream CSS classes that were accepted, that accepts an object, creates a lot of intermediate objects to generate a string, to basically just have the string in line in the source to begin with. And this actually removed a lot of things. So let's start. First, unifying Dream and class names. So that's okay, that was just, we have those classes. And this was what Dream was generating. So Dream was generating font style 16, long. So switching it to Tailwind, we just change it to this. All right, this was actually so, it was just like a day of work, maybe 2 days, like the PR was long, so 2 days. So basically what we went was map all the classes, because they were already systemly generated, and map them with that. So we didn't change anything to the core system. Nobody actually noticed. Like this project, the whole project was basically me working on this while 20 other developers were coding on the features. So I didn't want to block. So this was one of the constraints of this project. We couldn't just stop working. The developers are working, I'm just shipping this PR and nothing changes. So all work, that's great. Like now you can use those classes. Next step. Replace the Dream classes with TW helper. Okay, now we are talking. Now we get to the more tricky shit. So we have a lot of code like this in the system, where you get a div and you get a class name, and it gets these Dream class names. And if you notice, think about how many objects are creating here. Like, let's count. So we create one object for mobile, 1. We create one object for mobile desktop tablet. We create one object for mobile desktop tablet 6. Like we create 3 objects, 4 objects, think about it, this in a loop, 200 elements, 500 elements, how many objects are? And this needs to be looped through. So the way to replace this is we need to get this code and replace it to this code, which, if you look at the performance of the code here, it's a lot faster because you don't do any computation. Everything is already done. It's everything applied. You don't need to, like, there is no runtime cost for doing any of this. It's instant win. And actually, the funny thing is, code is a lot shorter, like a lot shorter, yeah. It needs some use to start reading it. Like somebody was joking that Tailwind is like Perl. You write it once and you don't read it afterwards because it's so chaotic with those names, but at some point you actually get used to it. So this is the TW function. I have a link, you can find the link in the slides because it's a very magic of TypeScript, but all that magic here is actually a compile time magic of TypeScript. If you notice the function itself, the TW function is just, it accepts classes and it returns classes. All the magic here is in the TypeScript definitions of basically mapping the whole Tailwind to be type-safe. And we didn't need to map the whole Tailwind, we just needed to map the classes we already generate from our own system. So why do we do that as an intermediate step? The goal here was, big problem with Tailwind is typos. So if you mistype a type in a class, it becomes confusing. So you just replace this with this function. So, okay, that's great, but we have 200, 300,000 lines of code. How do we go to all of this? Of course, not by hand, because I just have 2 hands, and one is doing something else. So I found, after some research, a tool called GS Code CodeShift. It's a tool from Facebook where you have this tool where you write this script called transform script, and you give it a file, and it can read the SAT, the syntax tree of the whole file. It reads the syntax tree and it can make changes on the syntax tree level. And you can do code transformation type safely by just transforming the AST. And then you do go to prettier just to reformat the code. So you actually can write code like that. So you just write a transformer, not in the AI sense, just in something that transforms code, into this GS code shift thingy. So you write this code that transforms the code. So this is, by the way, one of the biggest takeaways of this talk. If you need to do massive refactorings in your code bases, like first, don't do massive refactoring, don't do rewrites, do refactorings, step by steps, because again, every step I did right now, my developers were not blocked. There wasn't a point when somebody was blocked in the system. The second is, again, do it with system transformations, don't do it by hand. We have 2 hands and they need to do more important stuff. So how does CodeShift look like? This is how it looks like. It's very simple. You notice it's very readable code. Again, you just import this thing here, you do these other things here, you do some other, it's very complex, to be honest. I was like looking at their examples and I'm like, oh my God, I need to change jobs. Maybe I should go do plumbing or something, you know. So hopefully we are now living in the ChatGPT era and to the prompt engineering era. So basically what I did here was I say, okay, ChatGPT is good it's not very good for complex things, but it's good for generating code by specification. So you just generate me a function. So this is my prompt. So this is the prompt I wrote to write me a transformer. So I was like, let me say, because it's very slow. So I'm like, please use this GS CodeShift. Use this new version because they have the old syntaxes as well. And a lot of explanations how to do stuff. Here is an example. This is an example. You transform it to this other thing, and you just give it this tool. And ChatGPT spends like a good amount of time. In the old days, compile your Java project type of time, and it generates code. And the nice thing about it is we use TypeScript. We have a good build system. So what we can do here with transforming code is this code, I can run it. I see, oh, they changed 2 million files. If it compiles, it works, kind of situation, because we made all the steps beforehand. So this was basically my flow when working with all the transformations. I spent like 15 minutes just writing these deep dive specifications, like I'm telling a very dumb intern who is very opinionated and he thinks he's better than the whole world thingy. Write this to them, run the code shift, and then adjust the prompt a couple of times. It never gets it perfect, it never works perfectly, but from this point on, I can actually open my code and start doing the changes myself. So I can start refactoring the code that was generated. I couldn't make it, I didn't have a single pass where ChatGPT generated something and it worked perfectly, which is their story, to be honest. Like most of the AI generated code never works perfectly. So, but I had this forcing function that makes me know if I did the correct thing. And then I was just refactoring on my code. So actually most of my time was spent over here, just adjusting the code. And again, this part is, again, I needed to refactor these transformer codes to do all the work that needed to be done in this code thing. But, and this is some of the prompting tips. So again, we are in the age of AI, yada, 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 and so on and so forth, before the next AI winter in 2 months. But we need to talk about AI. So here's some prompting tips. So always when you do prompting for code, do start with like a code sample. Like give it from this, do this, from this to this. You're basically doing fine tuning. Then always be very careful with the negate statements. Those machines and the way they do all these embeddings and all them algebra don't work very well with don't. They're a bit like toddlers. If you don't tell them don't do that, they're going to do it. Because the negation is very complex with them, which is very surprising because technically negation should be just a manipulation on like a matrix, but no matter. They are not very good with negation. You need to give them all positive statements. Try always to frame the thing in a positive way because they kind of lose context in the middle. Also, a lot of people, what they have seen them do when they are having one session and they're trying to force their way into their single session. I'm creating sessions all the time. I find this as a feature, not a bug of LLMs, is I can just create a new session without any previous knowledge of the previous things they have done, because at some point they go to this auto-regression mode. So the way a lot of the LLMs work is at some point they start to auto-regress because one mistake in their logic compounds into all the iterations. So you just need to start from like a simpler state. And again, for more complex things, AI would get you to like 80%. Then you go to diminishing return zone where every improvement starts diminishing. And again, stop using it when you're stuck. Like I noticed, if I spend 2 times writing a prompt and the result is wrong without any progress, just go and write the code normally. Like refactoring is, I think in the new age, refactoring and reading code is going to be a very important skill because AI generates very ugly and stupid code and we need to be able to read it fast and validate it. And one tip which I just remembered, and I'm wondering why I didn't put it here, is it's very useful to have a forcing function. This either be an automated test, a linter, something that can validate your work. Because again, I was changing thousands, hundreds of thousands, like I think at one change, I think I had almost like 50,000 lines of code change in a single PR. And if I didn't have the type safety, if I didn't have all those checks, I actually even had unit tests for the TW transformation at some point, just because I wanted to be better safe than sorry. So this step was actually the one, it took me like half a week to a week, like 1 week just doing all of this with transformations. Like it was amazing that I think I changed maybe like 100,000 lines of code in like 2-3 days, just with those transformations. People thought I was the most fast typer writer in the world. I was like Speedy Gonzalez of typing, and I was just transforming. Step 3 again, inlining flex with text. Again, more of the same. Basically, when I found this trick of code transformation, it basically did the same. Switching to Tailwind. Honestly, switching to Tailwind was very nice, that was very easy because we already had Tailwind, which I just needed to change some config files, some styling like reset CSS and things like that. So the change was not that hard. And again, this was the final PR. Again, it was just like 3,000, 4,000, just changing some syntaxes. And again, ESLint handles type safety. We removed the bandage and everything kind of like worked out. And I was very intentional that I opened this PR on the 2nd of April, not the 1st of April, because my team was going to think I'm joking, that we are done with this project for like, because the whole project took like 3 weeks, basically a sprint and a half. And 1 sprint for like adding additional documentation. So it was a 2-sprint project, 2 weeks, to basically change half the whole system, rip out, basically open it and rip it gets out and things like that. But yeah, I shipped this on the 2nd of April, just because again, if it was on the 1st, people would thought this was a joke. Because again, most of the team actually didn't notice this change while they were working, because again, the core utilities was kind of isolating them. So some of the recap of the whole story and why I'm telling the story and not just giving you like bullet points, do this, do that. I find a lot of value in stories in general. I mean, we as a humanity have always shared things via stories, because the thing with the story is every person here who is listening and not looking on their phone or things like that is going to take different things, because there is different things each of us have as experience, things that we don't know, things that we know. And a story can trigger a lot of our neurons and a lot of the things in our heads to give us a lot of different perspectives. And that's the reason I usually like stories. I don't like people just telling me, do this, do that, do that. And I want people to see how they did it, because I can always get a lot of the insights. And like, again, one of the insights I wanted to guys to take about here is often refactoring is better than a poor rewrite. Often it's very easy to say, oh, we're going to rewrite everything because it starts safe. And we are not only going to rewrite everything, we're going to keep the old part and just do incremental moving. We're going to make all the stuff and be named legacy, and then just component by component or page by page. This never works. You will end up with like 3 legacy design systems in a whole system. So think about not a rewrite, but think about, okay, we have something. It works. It makes the business values. There is a good things here. How can we get rid of the bad things and keep the good ones? How can we just refactor our way to success? Another thing is when you do major system refactoring and restructuring, it's very important to have a safety net, to have a thing which makes you know that if you do something major, there is something to catch you. In my case, again, I didn't teach any functionality, I was just teaching CSS, but I have a lot of TypeScript. I spent a lot of extra time adding the type safety, making sure everything worked as intended. I actually had, again, unit tests that were testing that, oh, these class names work with those class names, just to have the forcing function. And this is also very well with the AI suggestions and tools, because again, AI creates a lot of bugs. Like when we added AI to our team flows, I noticed that the small stupid bugs were increasing because people were just tap, 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 tap. Oh, I'm going to do the test, tap, 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 tap. And they don't validate that the thing they do works. Like I remember when I forced my team that every time you open a PR, and it's like a major feature, I want you to record a 5-minute Loom video walkthrough of the whole feature. I want you to record this video every time you make a PR, because after you ship this, we're going to ship this into a Slack channel, and everybody on the team would know that we shipped this feature. And after a few weeks, half of the team was going to revolt about that. And I asked them, okay, why do you don't like that? And they're like, I start recording the video, and I noticed a bug, and I need to fix the bug. And I needed to record the video 5 times, and I'm like, that's what the video does. Like, that was the goal. Otherwise, you're just going to ship the 5 bugs. Then I'm going to revolt, and you don't want me to revolt. So yeah, this is some of the things here to think about, again, how to basically refactor your way into the success. So yeah, it's almost time to lunch, so yeah, you can now wake up. And thank you very much. All the slides are here if you need some links, other stuff, and again, my newsletter is over here. And now time to eat. Oh, I don't know, do we have questions? Do we answer questions? Do we have a Q&A set up? Or
yeah, there are questions, and we have 5 more minutes until lunch, so I will give the mic to the first one that raises hand, and then I will ask these guys here to give the mic to other people. Just to remind you that after the talk, the lunch will be on this direction, in the further stage. So there will be pizza and banica. If you don't know what is banica, you should totally try it.
No Thai food this time?
Sorry?
No Thai food this time?
There is only for special people.
Okay. Thank you.
Yeah, who raised a hand for a question?
Yeah.
Yeah, okay. I will ask you after the question to pass the mic to someone else.
Great talk, Rado, and really great story. I also believe the stories should be told because context matters, especially when doing such complex things like this. My question is, if you have to do this thing again, how differently would you approach this if you have to make another dream?
So the question is, how would I approach this differently? By this, do you mean the original dream system or the refactoring afterwards?
The original dream system. If you are on a project and it needs to have its own dream, how would you start it?
Yeah, so, I mean, I would basically do what we did there. So first I would start mobile first. This is again something a lot better. The other one is I'm going to think about the performance very early on the core component system performance. Like one of the problems with Dream was we started developing it rapidly. We started using it before it was kind of ready, which had its benefits. But the negative part is we never spent time thinking about the performance implication. Like the core issues were kind of like the performance implications of the thing. And right now, again, if I need to do, and I have did other design system afterwards. And honestly, having this, the refactoring and this for me personally learned me a lot about what not to do. It's kind of experience.
I have a question. Yeah. When you say performance, how would you measure performance if you have to start it again?
So if I have to measure performance again, and most probably, again, you can do some benchmark, but in this case, I would most probably think about simple computer science things like O1 and log 1 of like, okay, we are having this core thing in our system, and it's going to be code from everywhere. What is performance? Like just think it more holistically, like, oh, we are generating all those classes, where do they go, how do they clean them? Like in JavaScript, like how can we actually, where does performance problem, for example, in JavaScript come? Okay, one problem is bundle size, like, okay, we generate too much assets, too much JavaScript even. Like after this project, we actually had like a whole crusade around code splitting and just making the whole JavaScript bundle, because we were now attuned to this. So one with JavaScript is bundle size, because bundle size is not only time to download, but this code needs to be parsed, it needs to be processed, it needs to be run. The other one is, again, just loop and iterations. Okay, how can I make this loop to happen on the developer machine and not on the client machine? Like how, is there a way to do some, like we were thinking some things of, oh, maybe just in the compile step, we do some of the transformations there. Like we are doing stuff like this for now. So this is more like, again, on the holistic approach. It's not, yeah, you can measure it, but what do you measure and it against? Now, you can, for example, say, oh, I made this page and I expected page performance to be like that, but how do you measure the download bundle size performance? It's hard. So it's more like holistic thinking around the performance. And the second thing, again, is more thinking, again, and this is a terrible answer, but a lot of the API design talks come from experience. You need to work with great APIs and terrible APIs and migrate it between those two in order to have this sensibility of what's a good API. Okay. Somebody is raising hand there.
Thank you very much. Well, do you agree that component design system, first of all, is supposed to solve the problem with not tackling every single designer's design decision, so that you're primarily concerned with doing layout. Having that said, I mean, if you have a proper design system, you don't have to pass properties as shadows, colors. You just use some component and you don't have to specify font size. I think this is the primary goal of the Dream library, because you don't want to write those. Obviously, they are specified in the first version, and I saw that you were passing props like font size, which in my opinion defeats the purpose of having a component system itself. Then you decided to refactor it because obviously you are still concerned with CSS, and you used this library, Tailwind CSS. Mm-hmm. Well, this eliminated the components, and now you have diffs, and you are constantly putting classes, and you're, in my opinion, feels like you're deviating for having a component system, because you are more prone to actually missing some class, and having the abstraction of a component actually encapsulate the CSS decisions that are more concerned with design, and actually give the possibility to developers to do only the layout part. So if that is correct, what is actually the trade-off that made you do that particular thing?
Gotcha, yeah. So one thing so the question was, if you basically inline all the CSS into divs and As and buttons, didn't this defeat the purpose of a component system, and what's the trade-off and the balance, right? That was the question?
Yes, this is.
Yeah. So first, we didn't eliminate the components, like the button components, the form components, the card components. A lot of our high-level components are still there. I didn't change those. What I removed was components that were basically CSS as a component. And what we kept with Tailwind was, Tailwind has a lot more rich library with utilities. And again, we are making web, and with the web, you need to make 2 divs, 3 divs. You need to have the flexibility. Like, if you're designing a software, let's say you are designing a backend application software, where the design of the system is basically tables and forms, then, okay, you can have a very constrained design system. In practice, if you're designing a website or something more consumer-oriented, you need to be able to experiment with different and kind of deviate from the design system. And that's, again, where the tricky balance comes of the whole situation. Removing text and flex makes a lot more sense in practice, because otherwise you're basically making a React component that's a CSS thing. Because yeah, we wanted consistent shadows because we needed them. A lot of the shadows are used in like high-level components. But again, those are the primitives. If you think about a design system, oh man, I had too many slides here. Maybe it was like 20 slides. So if you think about this part of the design system, the core design system is, by all the books, is the grid, the font sizes, and again, we are not specifying every possible font size. Our font size is basically the same as the component. They have all the semantic names, like the way Tailwind says, you don't say font size 16, you say font small, big, like all the domain one. Font weights, color tokens, layouts, and this is the design system itself is more on an abstract level. Like the design system comes from the print world, and a lot of those are kind of the core system. What we did was we keep our layers split. Like before, we had a lot layers, and a lot of the code was coming from the top core component layer. Like the text and flex were used everywhere, and it was a lot of noise there. What we changed was we now have high-level components like button. It's definitely its own component. We had form, we had infinite scrolling. Like we have a lot of the benefits of commoditization of the high-level components. We had components like domain components, user card, user label, like things that are like wide thing. And we have the design tokens, which are the CSS classes of Tailwind, which are again constraining the design to match the system. And we have this middle ground, which we eliminated, so a developer can say, oh, here I'll just use 2 divs, or here I'm going to use 1 div. And if I need something a lot more complex, you still have the patchway. So we haven't eliminated the component system. We just eliminated a lot of the primitives, because what happened was we had a problem of mixing abstraction levels. Like we had high-level abstraction components like form, where the form has behavior plus a lot of UI orchestration and complex, and we had the tokens, which are the flags, which are the text and all of that. So we still had a very rich, like 200 component library, and we were still shipping fast. What we changed was kind of the implementation of the library.
That makes more sense. Thank you.
Yeah, thanks for asking, because I was able to kind of explain that. Cool. Any more questions?
Yeah, do you have time for one more?
Well, I have time. I mean,
Nice.
the food won't escape, hopefully.
Yeah. First of all, great story. I was expecting a nightmare story, but you pulled it off in the end.
I always want, I'm very happy in the morning when I wake up.
Yeah, you should be. And it sounds like a multi-year project that would be, migration you did in a sprint or two. But my question is, you mentioned that there should be a function that checks your changes. How did that function look like, to check 100,000 lines of changes?
So there were like two things. First, the transformer function, basically what the transformer was doing was it accepts like properties. And it says, okay, find me a call to this bad boy. Just let me find I like this picture so much. So much irony here, guys. Sorry about that. Okay, man. Okay, this function here, Dream CSS class name. So what I did tests were that my transformer accepts Dream with variety of properties and always generates the same class names. So this was one of my checks, right? The other check I did was I wrote a script which runs to our end-to-end test suite, and it recorded before the transformation what class names were attached to elements, and after the transformation, these class names match the same. So I basically created this big text file, like it was like a couple of megabytes of a hash, where it was like, okay, this element has this class name. Basically what I did was, this page has this class name. So we had a very expensive end-to-end test suite. So the end-to-end test suite just clicks through. So I added a plugin, which was like, after each test, open the page, find all class names, record it in a file, which is the test file, test number, like the test identifier, plus the list of those class names. When you run the transformer function, does the same file, class names are the same.
Like snapshot testing.
Yeah.
Verifying the snapshot.
Yeah.
Matches.
So basically, I make a snapshot of what class name should be before, and I do a snapshot what should be after on that particular case. For a lot of the forcing functions, needed to force my creativity how to test them and make sure they work. Like a lot of, after the initial steps, having the TypeScript tie-up, so if something breaks, I don't have a good syntax, works. But
Awesome.
For that work like this way.
Awesome, great work.
Thank you. Any other question? Okay, now time to food, because before the food to run away. Yeah.